Hello, so welcome to Physics with Amol sir. This video is for class 10, chapter light, part 2nd. So in the first part we saw about what is meant by light, what is meant by reflection, and we talked about spherical mirrors, concave mirrors and convex mirrors. In this particular class we are going to talk about image formation by concave mirrors. Okay, but before we start, there is one concept that we need to know, the concept of real images and virtual images. Now what do we mean by these two kind of images? First I'll show you what is a real image. We define a real image as an image which can be projected on a screen. Okay, so real image is an image that you can project on a screen. I'll show you what I mean. So this is a screen I have. Screen means a white piece of paper. Correct? I'm going to take a convex lens, a magnifying glass. On this side of the room, I am having my tube light. So let us see if I can project the image of the tube light on my paper. So if I move my convex lens, just about now you should be able to see. Can you see a white line on the side? Yes, that is a real image. Correct? Why is it a real image? Because the image of the tube light is actually falling on my paper, which is acting as the screen here. This image is called as the real image. Okay? And then next type of image is a virtual image. Virtual image is the image that you are seeing here. Okay, so this is a mirror. The images that you are getting inside a mirror, these are called as virtual images. Why are they virtual images? If I keep my piece of paper in front of here, I cannot see the image of this mirror on my paper. Correct? So no image is formed on the screen by a mirror. So the images on this side, this image that you are seeing right now, this is a virtual image that you cannot project on a screen. So once again, real images, image that can be projected on a screen, virtual images which cannot be projected on a screen. Okay, now let us begin. We need to know these kind of images because when we are learning about images formed by concave mirrors or by convex mirrors, they will form these two kind of images. So we should know which kind of image we are getting. Right? So let us start with the first one. So I hope you remember the first ray diagram that we talked about. Correct? Once again I'll remind you of those concepts. A concave mirror or a convex mirror. First we need to have the principal axis. Then where the principal axis will meet, that is called as pole. Then the center, that is the center of the sphere, that will be called as center of curvature. Then between the center of curvature and the pole we'll have the focus. Okay, so remember these concepts when we are doing the next part. The first thing, when object is placed at infinity. Okay, this is the ray diagram. So object is placed at infinity. So what do we mean by infinity? Let us understand. Infinity does not necessarily mean thousands of kilometers away. Let us say you are having a concave mirror that has focal length of 5 centimeters as an example. So if the object is placed at, let us say, 100 centimeters, you can say it is at infinity. Getting the idea? So even if the object is placed at 100 centimeters, which is much larger than 5 centimeters, which is our focal length, we can say that is the infinity. Okay. So infinity in our optics, it basically signifies a considerably large distance as compared to the focal length. So if we have kept the object at the focal length, I want you to look at the ray diagram. All the rays which are coming from the object, we are going to assume that they are parallel to the principal axis. This assumption we can make because the object is very, very far away. Correct? It is at infinity. And we have learned, I hope you remember, if a ray is coming parallel to the principal axis, after reflection, it will pass from the focus, which is what you see happening over here. Okay? All the rays. We have shown only 2 rays to keep things simple. Actually, there are thousands and thousands of rays which are coming. Correct? If we show that, the diagram will become too complicated. So we'll basically show only 2 rays. So you see the 2 rays coming. Correct? So 2 rays, they are coming parallel to the principal axis. After reflection, they are passing from the focus. Okay? And you will see all the rays, they are converging on the focus. Because they are converging on the focus, that is where you will get your image. Okay. Now what you can see, all the rays, they are getting converged. The image that will be formed will be very, very small. we say it is a diminished point sized image. So if the object is quite large, the image will still be very, very small. So if object is placed at infinity, image will be formed at focus. For a concave mirror, mind you, these things will be different when we are talking about convex mirrors. This particular discussion is only meant for concave mirrors. So the image will be formed at focus. It will be diminished. Okay, the size will be very, very small. Now, what kind of image it will be? Whether it will be real image or virtual image. Now, because all the rays are converging in front of the mirror, correct? So, because they are converging, it is going to be a real image. If you keep a screen at the focus, you will be able to see the image. Okay, so the image will be real. And the other property of this image, it is going to be inverted. Okay, as with respect to the object, the image that you get at that focus is going to be inverted. Okay, so if object is placed at infinity, image is formed at focus. The nature of the image is real and inverted. Okay, and the size is highly diminished, point sized. Fine. So if there is a confusion, again go to the ray diagram. Second case, that is when object is placed just beyond center of curvature. This is the ray diagram. So just beyond center of curvature means, let us say you have a center of curvature equal to 10 centimeters. Correct? So you can keep the object at 11 centimeters, 12 centimeters, 15 centimeters. That is what we mean by beyond the center of curvature. So if object is placed beyond the center of curvature, this is how the image will be formed. How do we make the ray diagram? First ray you will draw parallel to the principal axis. Correct? After reflection, obviously it will pass from the focus. So you can see that ray going from the focus. Second ray you will draw going from the top point through the focus. So the ray is going through the focus. A ray which goes through the focus, you will remember, after reflection will pass parallel to the principal axis. Is that clear? So the first ray we made, that was going parallel to the principal axis, it passed from the focus. Second ray we have made is passing from the focus and it is reflecting parallel to the principal axis. You can see the point where they are intersecting. That is where our image will be formed. So you can see the image being formed over there, that we have named as A dash B dash. Okay. Now what do we see about this image? The first thing you will notice is the position. Where is the position? Position is between C and F. Okay. The image has been formed between center of curvature and focus. Second thing you will notice, what is nature of the image? Nature of the image is once again real. Correct? Because again it is in front of the mirror. So it is a real image. Okay. And you can see it has been inverted with respect to the object. So nature of the image is real and inverted. And you can also see the size of the image. You can see the size has diminished. Okay. So this is the case for when the object is placed beyond center of curvature. Third case, when the object is placed on the center of curvature. So if we place the object on the center of curvature, this is the ray diagram. First ray will draw parallel to the principal axis. After reflection it will pass from the focus. Second ray again will draw passing from the focus. Correct? And after reflection it will go parallel to the principal axis. You can see where they are intersecting. You will find that the image is formed exactly on C. Okay, so the position of the image is at the center of curvature. So if object is placed on the center of curvature, image is also formed at the center of curvature. Okay, nature of the image will be real because again in front of the mirror. Next it will be inverted as you can see in the diagram. Okay, and size of the image is same as that of the object. Okay, so if object is placed on the center of curvature, image is also formed at the center of curvature. The nature of the image is real and inverted and the size is same as that of the object. Clear? So this is case number 3. Fourth case. Now we will be placing the object between center of curvature and focus. So if object is placed between C and F, then This is the ray diagram. Once again what we'll do, we'll draw first ray parallel to the principal axis, correct? It will pass from the focus. Now second ray we are going to draw as if it is coming from the center of curvature. Getting the idea? Now the second ray you will see is coming from the center of curvature, and obviously you will remember that a ray which is coming from the center of curvature, after reflection passes through the center of curvature once again. So that is how the second ray is getting reflected, and you can see the intersection, and that is where we are getting our image A dash B dash. You can see that the position of this image is beyond center of curvature, correct? It is farther away from C. Nature of the image, real and inverted, but I hope you are seeing the size of the image. Now the size of the image has enlarged. Getting the idea? So now the image has become enlarged. It is real, inverted and enlarged. Now next case, we are going to keep the object at the focus. If you keep the object at the focus, this is the ray diagram. First ray will draw parallel to the principal axis. It will pass from the focus. Second ray will draw as if it is coming from the center of curvature. It will pass again from the center of curvature. You will notice that in this case, both the rays are becoming parallel to each other. Are you noticing it? Because they are going parallel to each other, in this case, the image is going to be formed at infinity. Getting the idea? So in this case, if you keep the object at focus, the image gets formed at infinity. Okay? Because it is getting formed at infinity, the nature is real and it is highly enlarged. In this case, we get a good enlarged image, right? And next thing you are going to notice, it is going to be inverted image once again. Okay? So if object is at focus, the image is formed at infinity. Next thing you will notice that it is real, inverted and highly enlarged. Getting the idea? One thing you would have noticed is, as the object started coming close to the focus, the image started moving away from the focus. Correct? So this is an easy way to remember where the image will be formed. So when object was at infinity, image was at focus. When object started coming towards the focus, image started moving away from the focus. They came together at the center of curvature, and from center of curvature again they started to move away. So that is an easy way to remember. Now let us see the last case. This time we are going to keep the object between the focal point and the pole. Correct? So if the object is placed between focus and the pole, this is the ray diagram. Now this ray diagram you will notice is little different than the others. Let us see the rays first. First ray will draw going from the top point to the pole. Okay, we are not drawing any rays parallel to the principal axis in this case. Correct? I want you to think why we are not doing it. Correct? If you look at the ray diagram, it will make sense to you. So first ray we are drawing going to the pole. From the pole it will get reflected. Second ray will draw coming from the center of curvature, and again it will, after reflection, will pass through the center of curvature. This time you will notice the two rays, they are not converging. In fact, they look like they are moving away from each other. Is that correct? Because they are moving away from each other, it looks like they are coming from behind the mirror. Okay, that is why what we have done, we have drawn these dotted lines. Okay, and the dotted lines seem to come from one single point, and that is where we get our image. In this case, you get an image not in front of the mirror but behind the mirror. Okay, and this is called as a virtual image. Getting the idea? So if you keep the object between pole and focus, you get a virtual image. Now what do you notice about this particular image? The position of the image is behind the mirror. Correct? Next thing you will notice, the nature of the image is virtual and erect. This time the image is not inverted, it is erect and it is enlarged. Fine. So these are the cases for image formation by concave mirrors. Now you have to look at the ray diagrams once again. You have to practice drawing them, only then it is easy to understand. Okay, so this is the table I have put. In this table you are going to be able to see all the different positions for objects, the different position for the image, the nature of the image and their relative size. Okay, from the exam point of view, this particular topic is very important. Okay, we can be asked to make the ray diagrams or we can be asked some kind of numericals. Fine, so I hope it was understood. For any doubts, please don't forget to ask me. Next class we are going to see image formation by convex mirrors, and after that we will be solving some numericals on this.